Hey guys, in this session let us learn about the basics of fragmentation in Oracle database. I will be explaining fragmentation at a much deeper level in performance tuning course. Okay, so in this course let us just see what is fragmentation, why we do fragmentation, and the methods which we use to defragment the fragmented objects. Okay, so generally out of Oracle database, in general, what we call fragment. So if there are broken pieces of something, some object, okay, take an example. There is a mirror like this. Okay, so this mirror is broken into multiple piece of object. Okay, so all the individual pieces are called as fragments. Right, so they are broken into multiple tiny pieces, and they will be split into fragments. Right, so similarly in Oracle database we have tables. Right, so in tables data is stored in the form of blocks. Right, 8 KB block size. Right, so each block consists of some data, and those data will be used for business. Right, so we select the data, we insert data, update data, delete the data. Right, so just consider that so all these data blocks may not be always contiguous. So contiguous means they are not stored in a group or continuously. Right, so one after the other. So if you see this diagram, you can see that all the data blocks are stored one after the other. Okay, but in reality, whenever we do insert, update, delete, right, in banking databases, multiple DML statements will be executed. So when they insert some data will be inserted like this. Okay, when conventional insert is happening. Okay, and when we update data, we update the data blocks, and while we delete the data, what happened is some of the data blocks will be erased. In the sense, the data stored in the data blocks will be erased. Right, so just imagine that the data storage is something like this. Okay, we have lot of holes or empty spaces inside the storage. Okay, so all these empty spaces will contain nothing, and other layer of the disk. So here we have data, and here also we have data, here also we have data. So you can see that the data is scattered in the table. Right, so I'm just giving you an example for your understanding. Okay, so I'm not going into any technical stuffs, but in general how a fragmentation look like, I'm just giving you a demonstration. That's it. Okay, so when optimizer needs to generate an execution plan, so I'm just executing a select query, select star from this table where something where I will give some predicate. Okay, and it is telling the optimizer to generate an execution plan. So once the optimizer looks for the data from the table, what optimizer does is it scans all these empty rows as well, whether the data is stored in that particular empty space or not. Okay, why? Because optimizer may not know that the layer of the disk which stores the data is fragmented. Okay, so even in your Windows laptop, you may have some software to defragment all the space. so that you save a lot of unwanted space, right? So in this case, there are two issues. One is we lose space. Okay, why? Because how Oracle calculate the size of the storage is, so consider that this particular table size is 100 GB. Okay, so the total size is 100 GB. Okay, so when I delete all these blocks from the table, I have almost deleted just consider 30 GB of data. Okay, so how the space, how the remaining space should be calculated. So when I delete all the data from here, so the remaining is 100 GB minus 30 GB, which is 70 GB. Remaining 70 GB is the used space, and I should be having at least 30 GB of free space, right? But since delete will not reset the high water mark, okay, so I will come to high water mark later. Okay, truncate will reset the high water mark, but delete will not reset the high water mark. What it does is delete will remove all the data from the storage, and it will leave those storage as empty spaces. It will not reset the empty spaces and store the blocks together, which is contiguous. Okay, so don't get confused about this technical term. Okay, to be simple, contiguous means continuous, that's it, or grouped together in a sequential way, one after the other. Okay, so how previously the data blocks were stored, right? Previously I had shown you, right? So if one block is like this, all the blocks will be in a sequential manner together. Okay, but if the data blocks are stored like this in the disk, and these are empty spaces, then these are not contiguous, but this is contiguous, which means there is no hole or there is no gap in between. But non-contiguous means there will be gaps like this. Okay, so in this case, even though I delete 30 GB of data, still when I see the used space, it will show as 100 GB. Okay, it will not reduce from this 100 GB and give me the used space as 70 GB. It will not give me this result because of fragmentation. Okay, so what I need to do is I need to reorganize, which means I need to tell the database that I don't need all these empty spaces. I just need to make sure that all the blocks are contiguous and just remove these empty spaces so that I can save space and use that space for some other object, right? 30 GB is not a small size, right? I can store 3 10 GB tables or 6 5 GB tables, right? Storage is very important. So that's the reason we defragment the data. Defragment the empty spaces from the storage. Okay, the second one is performance issues. Okay, so as I already told you, optimizer generates an execution plan, right? But optimizer may not be aware of these empty spaces in the disk. So what it does is optimizer scans all these empty spaces unnecessarily. Okay, so consider that these empty spaces comprise of 30 GB, right? So optimizer unnecessarily estimates the resources for these 30 GB scan. Okay, optimizer will use CPU for this false storage. False storage means there is no data in these empty spaces, but still optimizer will allocate CPU resource, memory resource, and scan all these empty spaces unwantedly. And just imagine how much time it would take for scanning these 30 GB unnecessarily. Just imagine, I just need to scan only 70 GB of data, which just assume that it will take 1 minute or 5 minutes. Okay, just an example. But optimizer scans all the 100 GB, thinking that the size of the table is 100 GB. But in reality, already 30 GB of data was deleted. The table size is only 70 GB, which actually takes 5 minutes. But in this case, optimizer includes these empty spaces and just consider that it scans additional 2 minutes for these 30 GB of data. So instead of taking 5 minutes, it will take 7 minutes. Okay, so this is just a simple example. Just imagine if the size of the table is in TB, okay, then how much time it would take, right? If there are millions of rows, and if the same 5 minutes is 1 hour, just imagine, okay, in real-time production. This is just a simple example, but in reality, just imagine if a query is taking 1 hour to execute, right? And if the optimizer is allocating resource for scanning the empty spaces as well, just imagine, plus we can add another 1 hour or another 45 minutes. So just imagine how much time for every query which is executing on the database it would take. Okay, only for one query we are facing this slowness. So if there are hundreds of queries executing, then definitely every query which is inside, which is entering into this trap will get performance issue. So that is the reason it is the duty of the DBA to defragment the tables so that we save space and performance, right? But it is not always feasible in a production system. Okay, don't think that it is as simple as that. Okay, why? Because if there is a banking sector or any critical environments, always the table needs to be up and running. Okay, so we either can do the defragmentation online or offline. Okay, that will come, that we'll see later. Okay, in that case we will not be able to get application downtime in the first case. Even though we get application downtime, we need to estimate how much time it takes, right? Before doing this activity, we need to estimate the time. Also, if we do it online, we also need to make sure that there is no performance issue. Why? Because if it is a production system, always there are a lot of risks in defragmenting the data, right? So you can see this image. So this image contains fragments of mirrors, broken mirrors. Okay, so just correlate this example with how the data blocks or the data is fragmented in the disk, right? So you can just have these notes for your reference. Okay, I have just explained you a generic way to understand fragmentation. Okay, so here you can see another example, right? So two athletes are competing each other. One athlete is running on a flat surface and another athlete is having some hurdles. 3 hurdles are there. Okay, so just think which person complete the race first. Just think it in a generic way. We don't need to think in an advanced or we don't need to complicate stuffs, right? So the person who is running on the flat surface will complete the race first, right? If we think in a logical way. Why? Because the person who is running on a obstacle, right? There are a lot of obstacles. Person who is running on top of the obstacles may slow down, right? May slow down at this particular hurdle. Then again, when he meet the second obstacle, he need to slow down. So this is where the second person will not be able to complete the race faster compared to the guy who is running on the flat surface. So this guy runs first, right? So similarly, just consider the same example for fragmentation as well. When optimizer scans the data, if all the data blocks are contiguous, but which is not actually feasible in a real-time production system, right? But just imagine, if we defragment and reorganize the data, optimizer can easily run on a flat surface, right? Without any hurdles. But if optimizer has lot of hurdles like empty spaces, so these hurdles are empty spaces, just consider. It cannot scan the data blocks. Unnecessary hurdles or obstacles will be there, right? So if you see the next diagram, you will be able to understand this. This is the diagram. So this is the generic architecture, right? End user is running select query, select star from sparse table where salary less than 1000. This is just an example. So it is entering the memory. Okay, inside shared pool, all the checks are done and data blocks are scanned from the disk. Okay, so in the disk, you can see that for one particular table, all the data blocks, all the data storage are contiguous, which means they are continuous, right? These are contiguous blocks. But on the left side, you can see that there are non-contiguous blocks, which means you can see there are a lot of gaps in between the blocks, and also blocks are scattered over the storage, right? One block is here, another block is here, and another block is here, another block is somewhere else. But here you can see all the blocks are contiguous, and also you can see a lot of empty spaces like this. So these are the fragmented space. Fragmented space means just imagine the same example which I had given earlier. So if I just delete this block, okay, again if I delete this block, this becomes an empty space, which is called fragmented space, right? So likewise, there were blocks stored, red blocks stored in these white spaces, but they were removed because someone had issued a delete statement. Okay, the end user had issued delete statement because he no longer needs those data. Okay, that's why those space became fragmented. So in this case, when optimizer scan the blocks, it has some hurdles like we seen in the previous example, right? So this guy is having a lot of hurdles which for which he is slowing down at this particular point, and it takes a lot of time for this guy to finish the race, right? But this guy does not have any hurdles and he ran faster and completed the race first. Likewise, when optimizer scans these blocks on the right side, it can easily pick up all the blocks and give the results to the end user. But here optimizer needs to scan all these empty spaces unnecessarily and also need to scan the other blocks. So that is why in this particular side it will take a lot of time, which causes performance issue. But on this side it will be easier because we have defragmented the data, or the blocks were not deleted. Just imagine or just assume. Okay, and I had mentioned high water mark in the previous example, right? So what is high water mark? So just imagine, so there is a vessel. Okay, so in a vessel we just pour some water. So we are pouring some water. Okay, so in some vessels they mark some high level, okay, like 1 milliliter, something like this, and 500 I mean 1 liter, and 500 milliliter, something like this, so 100 milliliter. Okay, so 1 liter is the maximum level, okay, that we can store the water inside this vessel. So beyond that, water will overflow, right? So if we store beyond this point, water will overflow. For that reason, they use some mark, right? So this mark helps us to identify that how much water is stored inside the vessel, right? So if we store water until this mark, that is the end point, or we can no longer store water beyond this mark, right? So below that we have water, we already know that. So likewise, we have a high water mark which tells that below this high water mark we have data stored, okay, but above the high water mark we cannot store data, okay, unless until there are some exceptions where we can store load data above the high water mark. Okay, I'm not going to explain much deeper onto that, but just imagine, okay, just understand what a high water mark is, that's it. Okay, so whenever we insert data with conventional path, data will be inserted below this high water mark. Okay, and whenever we delete data, right, this high water mark will not be reset. This high water mark will be at the same point. Okay, but when we truncate data, this high water mark will be reset, which means, just I'm giving you the same example. So I'm just removing water from this vessel. Okay, so I have removed water. Not the full water, but I have removed some water from this vessel. Okay, so if I just truncate the data, so just correlate the same example with the storage, data storage. If I just truncate the data, all this water will be removed and this water mark is there, right? This mark will come down, saying that this is the high water mark, and below this high water mark I have data stored. Okay, it will just erase the previous one. This mark will no longer will be there when we truncate the data. Okay, but so when we delete the data, what happens? The same water will be removed. Okay, but the water mark which was previously used will not be reset, which means the watermark will be there like this. Okay, whether there is empty space here or not, it does not bother. So all this space will be wasted, these empty spaces, right? So previously when we truncated the data, the watermark was here, right? It reset the watermark so that below this watermark we have some data. But when we deleted the data or water, the watermark will not be reset, it will be staying here itself. That is the main difference, right? So similarly, just correlate the same example with the blocks. So when we delete the data, this watermark will stay here itself, even though I have empty spaces. But when I truncate the data, all these empty spaces will be removed and high watermark will come down. Okay, so I will explain all these concepts in a deeper level in the performance tuning course. Okay, so as of now, hope you would have understood what a fragmentation is and what a high watermark is. So let us just use this formula. So this is just a formula with some notations, and you can see the legend where we have the abbreviation of all these notations. So Emax means max extents. Okay, and sum of all extents, and ET stands for total number of extents. So we are dividing Emax divided by the sum of all extents and the whole divided by total number of extents, and we are multiplying with 100. Okay, and this is the query to detect fragmentation at table space level. Okay, so we can check the fragmentation at the table space level and check which table space is fragmented the most. Okay, so generally undo table space is not of much importance. Why? Because undo table space will reuse the extents whenever the read consistent query is completed, right? So we don't focus on undo TBS. Okay, we always focus on application tables or application table spaces. Why? Because we give much importance to the business data, right? So whenever we consider performance, the application queries needs to be faster compared to the undo table spaces and all. So this undo table space will be automatically managed by Oracle, so we don't need to bother about it. Okay, so users table space is the one we need much importance. So even sysocs and system are secondary. Okay, so sysocs table space are fragmented because it contains lot of AWR information and optimizer statistics information, and lot of performance related data will be stored in sysocs. So we need to make sure that all the snapshots are properly managed and all those details. Okay, but even sysocs is also much importance. Okay, but compared to application table space, sysocs is not. Sysocs is secondary. Okay, and system is also very important. Why? Because system table space is the very important table space in Oracle database. Without system table space, bootstrap data will be corrupted. So if we do something, if we reorganize something on system table space, then that's it, database will be corrupted. Okay, that is the reason it is always very important that we don't touch system table spaces. Okay, unless until we know what we are doing. Okay, but in live production system we should not touch system table spaces. Okay, so we can see that user table space has fragment mark as 19 and it is highly fragmented. Okay, always make sure that this fragment mark is less than 20. Okay, so if the fragment mark is less than 20, then we need to defragment those table spaces. Okay, so just consider this as a threshold for defragmenting the data, right? And we have another query to check the high water mark of the table. right? So we have a lot of tables here, okay, and high water mark, this is the column which denotes the high water mark, and available space and data below the high water mark and total number of rows. So we don't have any table, okay. So we can also simulate the fragmentations, okay, just delete some rows, okay, so that we can simulate the fragmentations. So these are just typical examples that I have given for you for reference, okay, so that you will be able to understand fragmentation much better. So we already have this table called XTBL, right? So you should have created this table, okay, but I have recreated this table, okay. So just delete some data from this table, okay. So we are just going to simply simulate the fragmentation, okay. So in my database I have almost 1 million rows, so in your database it may be something different, but the end goal is to simulate something, that's it. So just delete some data. So delete from this table where salary between so I'm just trying to remove some rows out of these rows, okay. Okay, so I have deleted some rows. Likewise, you can also randomly delete some rows. You can either specify salary or you can specify city or something like that. The end goal is to delete some percentage of rows from this table. So I'm just committing these data, okay. So now I can insert some data as well. So hope you have this sample table script, okay. Just insert some random data. I commit the data. So now let us again check the fragmentation with the help of this script on users table space. So now you can see that the fragment mark has been changed, okay. It has been changed to 20 and highly fragmented, and we have some fragment graph, okay. So if there is no data in fragment graph, that means that that particular table space is highly fragmented, okay. If we have some value or some symbols here, then that means that that particular table space is not that much fragmented, okay. So the higher the fragmentation, empty the data, and lower the fragmentation, there will be more symbols, okay. So previously we seen that users table space was having 19, but now when we deleted some data, it has increased, okay. But the end goal is the fragment mark should be less than, or I mean not less than, it should be less than or equal to 20, okay. Even we can consider 20 or 25 or 28 as well, okay. But as a rule of thumb, just make sure that we if the fragment mark is 20, then we can just defragment that particular table space, right. So now let me again run this table script. So now still we don't have the table XTBL under this list, okay. So let us go to the action plan, right? So there are multiple methods to defragment. So what we can do is we can import the fragmented table. Okay, exptp, we export the table, then again re-import the table. Okay, but this is not feasible in a production system, right? So when we export the table, and we can easily export the table, but when we re-import the table, we should make sure that the table is replaced, right? It cannot be appended or it cannot be recreated as a new table. So the existing table needs to be recreated. So that is not possible in a real-time production system. Okay, if it is a test system, then we can do it, right? So this option is not at all feasible. The other option is to move the table. Okay, so moving the table is the most common way to reorganize the fragmented tables, to defragment the fragmented tables, right? So what we do is we enable row movement, okay, which means we are we make sure that the rows are moving when we move the table to a different table space or the same table space, right? So once we move the table, all the fragmented spaces or the empty spaces will be removed, right? So just consider the same example. Data blocks are like this, scattered, and these are the empty spaces. So when we move the table, what happens is these empty spaces will be removed, okay, and these data blocks will be moved to the empty spaces, and it makes sure that all these spaces are used for other table storage, other object storage. Okay, so this is what happens. Okay, so let us just do the same thing, right? So let me just move the table. So there are two options. Okay, again, it is not as simple as that. So before we move the table, let us just consider the scenario. So there is a need to save storage for the databases from server, and also to enhance performance issue in the database. So that we need to take action as a improvement to get recognition. So we are getting some hike. Okay, so for that hike, we need to make sure that we are doing some improvement on the database. So in this case, for this reason, we are doing fragmentation. Okay, so I'm just giving you a simple example. Okay, in as if like we are doing it in a real-time system. So whenever we move the table offline or online. So there are two options available. So when we move the table offline, it will be faster and downtime is required. Why? Because the table will not be available when the move operation happens. But when we do it online, the move operation will be slower. Okay, but the application can access the table during the online phase. Okay, so in this case, there are a lot of trade-offs between offline and online, right? Offline is faster, online is slower, but during online we may also get some performance issues. Why? Because if lot of insert update delete happen in this table which we are moving, right? So this alter table online option will wait for this insert update delete. Until these insert update deletes are completed, it will this particular operation will continue. It will not interrupt this insert update delete. Okay, silently it will wait. So when this insert update deletes are getting over, okay, again let me just rebuild the index and continue the operation. Okay, so it creates some snapshot tables and store all the data inside that snapshot tables. From that point of snapshot, it will continue. Okay, these information or these internals will be explained in the performance tuning course. Okay, so here when we move the table offline, the index will become unusable, which means generally how the data will be stored is in table, data blocks will be like this, stored like this, and in index we have tree structure. We have a root block, okay, and we have lot of branch blocks, and those branches contains lot of leaf blocks, similar to a tree structure. Okay, so this is the algorithm for index, right? So similar to how we if we have a book, if we buy a book, so we have contents page or index page, which contains all the page number and the topic, right? So when we see the topic, we can easily check the page number and go directly to that page number faster, right, without in need of searching that particular topic on a particular page. So similarly, this index will mark all the, similar to the page number, it will mark all the data block number, right? So each and every data block may be having some address, and those address will be linked. Okay, so there's a pointer between the index and the table. So that pointer will point to each and every address of the data blocks. Okay, so when we move the table, right, so when there are fragmentations and when we move the table, all these blocks will be moved, right? The empty spaces will be removed and these blocks will be moved somewhere else, but the index pointer will be pointing to the same location, but there will be no blocks stored. Why? Because those blocks were moved as part of move operation. We defragmented the data, we reorganized the blocks. That is the reason that index will no longer be useful. Okay, even if the optimizer try to scan the index, the index will be unusable and optimizer will skip that index. It will not use that index, right? So for that reason we need to rebuild the index. So what is rebuilding? Rebuilding means we need to make sure that all the pointers are updated to the updated block location. So if this block was there here and it moved to this particular address, then index pointer also needs to be updated. Otherwise that index will no longer be useful. Okay, so for that reason we rebuild the index. So only during offline operation we need to rebuild the index, not during online operation. Why? Because during online operation automatically index rebuild phase will be taken care by one command, which means Oracle automatically takes care of the index rebuild phase. But for offline phase we need to move the table first and then separately we need to rebuild the index. And again it is not as simple as that, right? We need to make sure that we estimate the time taken for the table move and index rebuild to happen. Why? Because we always need to ask for the downtime, right? If we are doing offline operation, we need to ask downtime to the business, right? So how you will decide whether I need 5 hours or 6 hours for this particular index, right? If a particular table is 10 TB, then how you will decide how much time you need? Okay, so technical steps anyone can execute, right? If you refer the My Oracle support notes, you will be having a lot of documents for reorganizing the tables. Okay, you can easily get the commands and you can reorganize the table faster. But these skills comes by experience, right? So we can rebuild the index with the help of alter table commands, but in the real time in a production system it is too tedious to decide how much time it will take, right? If the size of the table is 10 TB, then how much how can I estimate the data, or how can I estimate the time taken for the operation to complete, right? I need to get some baseline. Baseline means I need to know that the particular table was already taking this much amount of time. So I need to initiate a baseline, which means I don't know any information about this table. If I'm doing it for the first time, I don't know. I can take a backup time. So I can just take weekend, right? I cannot do it on weekdays because during weekdays the table will be accessed. So if client agrees that during weekends these tables can be maintained, we can just get 2 days of time and just observe, right? If we have sufficient resource, that is another thing. If we don't have sufficient CPU memory, then that will take a lot of time. But if we have sufficient resource, then we can use a lot of parallel, right? Using parallel can speed up the process, and we can try to complete in 2 days. And we need to observe how much time it is taking. We need to note down the time so that the next time when we do, we can easily estimate the time taken for the operation, right? And we should also start the activity early when we do it on weekends. So Friday evening, once after the business time is over, immediately we need to stop the activity without any time delay, right? Otherwise it may be if the particular maintenance operation is happening till Monday, till the business hours, then that may also cause some trouble to the business, right? We need to make sure that we complete the activity before Monday 12 a.m. right? And we cannot always guarantee that there will not be any issue during the move operation. Even when we move the table, there may be corruptions. This is one of the examples. So likewise, a lot of issues may happen, right? And always we need to make sure that we get buffer hours, extra hours for troubleshooting in case we meet with an issue. So likewise, we need to more than technical skills and the steps to complete this maintenance, these experience and management things are very important, right? And also for rebuilding the index. If the index size is 1 TB, then we need to make sure that we have sufficient space in the table space. Not only for rebuilding, but also for moving the table as well, right? This example is not only for index, for any operation or any activity that you are doing. Just make sure that you have additional space in the table space where these tables are stored, and we have temp space for doing all the temporary operations, right? So always whenever we rebuild the index, temp space is very important. Why? Because index maintenance always takes a lot of temp space. So if the size of the index is 1 TB, we make sure that always the temp size is double the size of the index, which means I should be having 2 TB of temp space. Okay, this is for safer side. Okay, sometimes even rebuilding the index may take more than 1 TB. We cannot exactly have 1 TB of temp space. For that reason, we should have always double the size of the temp space, and also we make sure that undo space is sufficient. Okay, so this is for any activity that we do on the database. But specifically when we move the table, we often consider these all these precautions before we do. Why? Because just imagine if 500 GB the index size is 1 TB, and out of 1 TB 500 GB of the index data is rebuilt, but remaining 500 GB is there. It took almost 10 hours to finish or progress 500 GB. So after 10 hours you get this error. We already seen this error, right? Ora 1652 temp space issue, which means while rebuilding the index, Oracle is not able to rebuild the index further because of lack of temp space. Why? Because you already consumed 500 GB of temp space, and remaining again it needs another 500 GB. Just an example, okay? Whether it may be 500 GB or even 1 TB, we may not know. But after you wasted almost 10 hours of downtime, if you just end up with this issue, just imagine what may happen, right? You cannot continue the rebuild as well. Once 500 GB of index is rebuilt, you cannot continue from this 500 GB. If you restart the index rebuild, again you need to start from 1 KB or 1 bytes from the beginning. So it is kind of reinitiating or restarting the same operation again. So again you need to spend 10 hours for completing this 500 GB out of this 1 TB. So you have wasted almost 10 hours of downtime, right? So that is the reason, if the size of the index is huge, always make sure that you have all these considerations into your mind. Okay, if the size of the index is very less, okay, if it is just a 500 MB of size, then that does not matter. Okay, but in larger environments, it is very important that we need to make sure that we consider all these factors, right? So first we check the space or the size of the table and the index. Okay, before moving, I just check the size. Okay, so once I check the size of the table, what I will do, it is only 80 MB. So it is very, the size of the segment is very small. Okay, also I need to make sure that what are all the index for this table. So I can check in DBA indexes, where table name is equal to this table. I make sure that the index name is this and the status is valid. Okay, so I will check this index size as well. Index size is only 31 MB. Okay, so once I check the size of these segments, I make sure that I check the temp space, whether I have sufficient temp space or not. Okay, so I almost have 2 GB of temp space, 2.5 GB of temp space, so I don't need to bother about the index rebuild. Okay, index size is only 31 MB, which is very less. Okay, also you can check the size of the undo as well, right? So for undo, just divide this value, and almost even for undo I have 2.8 GB, so I don't need to bother about the undo space as well. Okay, and I need to make sure that on which table space this particular table is residing. So this table is residing under users table space, right? So again I need to make sure that I have sufficient space under users table space. So for temp and undo, we have checked the total space, but we have not checked the used space and free space. That is very important again, right? So when I just check the storage, so this is the total space available, but that does not mean that this 2 GB is available for our activity or not. Even out of this 2.5 GB, 2 GB may be occupied by some other process or sessions. We may not be knowing that. Okay, this just denotes the total space. That's it. Okay, but I'll just help you with identifying the free space and the used space in another session. Okay, since we have sufficient space, we can start the activity, right? So in another session about I will be explaining about the table space and how to identify the used and free space and how what are all the table spaces and all the details. Okay, so you don't need to worry about that. So now I can directly execute the move operation. So alter table name. First let me move it online. The schema does not support online move table. Why? Because we are in sys schema. Okay, so let me just create a user, or let me just, so you can also create an user. Okay, I have a user called test, so I will just connect to that user and I will just create a table called xtbl under test user. Okay, and I will also create I will just create an index called test index on this particular table and salary. Just create a random index. Okay, so now let me just move this particular table. So when I just move it online, it takes a lot of time. So let me just set the timing on. So it took almost 3 seconds for online move to complete. Okay, so now let me just check the status of the index. Owner is test. Now you can see that the status of the index is valid, right? So as I already told you that whenever we move the table online, always Oracle automatically takes care of the index rebuild phase. So we don't need to manually rebuild the index. So that is why it is still valid. Okay, so now when I move the table, what happens is all the empty spaces, fragmented spaces will be removed. So now let me just check the same query, whether we were able to reclaim some space or not. So now you can see that the fragment mark has been increased to 21, right? So it should not be less. The fragment mark should not be less. If it is very less, then that means that the table is highly fragmented. But previously we got 20, but now it has increased, right? So that means that we were able to reclaim some space. That's it. Okay, so now let me show you the offline move. So if I just specify without any class, so by default when you specify alter table name move, it by default takes offline move. Okay, so when I move the table offline, this table cannot be accessed, which means this table will be having downtime, but the operation completed faster compared to online move. So here it took 3 seconds, but here it took only 0.5 milliseconds. Just see the difference, right? So but during this online move, application can access this table, but during offline move this application cannot access this table. That is the trade-offs. Okay, so now you can see the difference, time difference and performance, right? It completed the move very faster compared to online move. So now when I just check the status of this index, you can see that status became unusable, right? Which means the index pointers became invalid because we defragmented the table and all the blocks are moved and the index pointer needs to be updated. Whether the blocks are moved or not, by default this offline move will make the index unusable, saying that this index can no longer be used and it needs to be rebuilt, right? So now what we can do is we can rebuild the index, alter index name. If we specify only rebuild, then that means that this index will be rebuilt offline. Again, similar to online offline table move, we also have options to rebuild the index online and offline. So if we rebuild the index online, that means that application can access the index, but the index rebuild will be slow. But when we do it offline, application cannot access the index, but it will be faster. So let me just rebuild the index. Now it took only 1 second, 1.3 seconds to complete. So now if we check the status of the index, it is valid, right? So after every alter table move operation with offline operation, we need to make sure that the index is rebuilt. We should not forget that. Okay, so now let us just rebuild online. So it took 0.2 seconds more than that. Okay, but in reality this may not be the same case. Why? Because in reality the index may be accessed by multiple application sessions, or the table may be accessed by multiple application sessions. During that time it is not as simple as we executed in this test system. Okay, so I will also explain the performance related aspects in the performance tuning course. Okay, since this is since the scope of this course is not to focus on performance, we don't focus on how optimizer is scanning all those information. Okay, so this is how we can defragment the fragmented tables, right? And also we need to maintain the index after we defragment the data. The another option is to export import, and there is also another legacy option. Okay, we can shrink the space. Okay, but in general we always use this method, alter table name move, right? Again we have other settings as well. We can use parallel for faster move. So if the table size is very big, then we can use parallel option. Also we can use no logging. Okay, so whenever we don't specify this no logging, during those times we may get lot of redo log generations. Okay, lot of checkpoints may happen, which may slow down the database. So we should keep in mind that we use no logging, so that redo logs are not generated during alter table move operation. Okay, also it is not mandatory to enable row movement, but as a good practice we can enable row movement as well. Okay, so this is how we can defragment the fragmented data.